Hey guys, so I'm still having a lot of questions about 7.4 and bootstrapping. So I figured I would go over some of that with you guys for our sample problems. So we'll start with number 2. They tell us here is a sample of amounts of weight changes of college students for their freshman year. And they give us our samples, and then they give us 10 bootstrap samples from our original data set. So the first thing we want to do is identify our confidence interval. So you'll notice in the problem for part A and B, they say use only the 10 given bootstrap samples. We want to construct an 80% confidence interval estimate for the mean for part A and for the standard deviation in part B. So they do give us our confidence interval level, which is 80%. So if you guys remember, the way we find our percentiles or our endpoints for our interval is based off of what we're confident in and what we're not confident in. So if we think about our normal bell curve, and I'll redraw this line so it's a little straighter. If we're confident in 80% of what we know, that leaves 20% to get to 100. So there's 20% we're not confident in. And we have to split that portion of what we're not confident in over these two tails. And that's why we divide it by 2. So that would leave 10% in the beginning that we don't understand and 10% that we aren't confident in. I guess I should say confident instead of not understanding. So this is exactly the same as the way we find our alpha. So our alpha, remember, is just 1 minus our percentage that we're given. So if we're given 80%, we're doing 1 minus 80 as a percent, which means we're just converting it to a decimal. So that makes our alpha 0.20, or that 20%. But remember, we're splitting it over the two tails, so we always take our alpha and divide it by 2. So our alpha divided by 2 is just 0.20 divided by 2, 0.10, or 10%, which is exactly the same as what we were talking about over here. So if we're thinking about it in terms of a number line, which is part of how our graph functions, because remember, a bell curve is just like on a normal scale. So if we're starting here at 0, our bell curve is just going to bring us all the way up to 100%. So if we're confident in the 80% that's happening from here to here, that just leaves the first 10% that we aren't confident in to be this portion, and the last 10%, which would end here. So we want the amount of space here to take up 10%. So we're going to make this portion of the interval from 90% to 100, which would be the last 10% of the bell curve. So since we're confident in 80% in the center, we're only not confident in the 10% on either side. So that would be from 0 to 10 on this side, and from 90 to 100 on this side. So that's how we get our percentiles, which we'll plug into StatCrunch once we're ready to use them. So our percentiles are going to be 5. Oop. Are going to be 10. I don't know where I just got 5 from. Be 10 and 90. And that's where those come from. So just a side note on where our percentiles come from, I'll go over it again in the next one, but just a more in-depth example of what our alpha is talking about and why we do alpha divided by 2, and a more in-depth picture of why we do it. So now that we're done with all of that, we'll erase all that, and we can now go into manipulating our bootstrap samples. So to open our bootstrap samples, we want to make sure we click this blue window here to open everything in StatCrunch. Then usually it takes a little bit, sometimes gives me an error, but it looks like everything's going well. So you'll see that they gave us our 10 bootstrap samples all in columns. So we can go to Stat, Summary Stat, by column, and we want to make sure we select all of our columns, so samples 1 all the way to 10. And in our problem, we're using the 10 given bootstrap samples to construct an 80% confidence interval estimate of the mean and of the standard deviation for part B. So just to save ourselves some steps, we'll calculate them both at once. So if we go back to StatCrunch, we're going to be calculating our mean. And if we want to select more than one statistic, but not many in a row, you can use Command if you're on a Mac or Control if you're on a Windows or a PC. So if you want to select multiples, you can select Shift and it'll select everything in between those 2 points. But we only want mean and standard deviation. So we'll select mean. For me, I have a Mac, so I'll hold down Command and we'll press standard deviation just to find those two. And then our last step, because we're going to be using this in the calculations for our percentiles, we're going to want to store it in the data table so that we can use it later. Whenever we don't store it in the data table, it just exports as a window. So I'll give you an example of that. So if we forget to select this and we hit compute, it'll just put everything into a window and we can't use it for more information. So if this ever happens, don't worry, you can always hit options and then edit, and it'll bring you right back to where you were. So it's just an example. So we're going to want to make sure we store it in the data table so that we can use it. Then we'll hit compute, and we'll get a little window that congratulates us on making some new columns. And then we'll see here in the headers, we know this is our mean column and this is our standard deviation column. So now that we have our columns made, we can use them to look up our percentiles that we found earlier. So all we have to do is go up to Stat, and we're going to go to the same place, Summary Stats by column, because our information is still given in columns. And we want to scroll down and only select our mean and standard deviation. Again, you can do them separately, but just for time, we'll do them together. And since both of them are an 80% confidence level, we're going to skip everything in between and just go down to our percentiles here. And we just want to enter the percentiles we found in the beginning. So we're just going to put in 10 and then use a comma to separate them, and then 90. So once that's all set, we don't have to store it in the data table because this is our last step. So we can just hit compute. So it'll give you a lot of numbers in between, but if we scroll all the way over, they'll give us our 10th and 90th percentiles, and that's what we'll use for our intervals. And remember, we're using them because our confidence was 80, so it ended at the 10th and the 90th percentiles. So our interval goes from here to here, and that information is what goes in our interval notation. All right, guys, so moving on to our second example in section 7.4, we're going to go over question number 3. So they tell us, in a study of accuracy of fast food drive-through orders, a restaurant has 37 orders that were not accurate amongst 417 orders that they observed. So using the bootstrap method to construct a 90% confidence interval estimate of the proportion of orders that are not accurate, use the 200 accompanying bootstrap samples, and then how does the result compare to the 90% confidence interval that they're giving us here? So The first thing you want to pull out from this that's important is that we are measuring a proportion of our orders. So if you guys remember proportions, we were always measuring whatever our variable was out of the total, or n. You want to think about it that way. So for this problem, we're looking at the number of inaccurate drive-through orders. So we would be looking at drive-through orders out of our total, which they tell us in the problem. So they say out of 417. So we actually are given an n that we now know of 417 because the total number of orders observed. So what's going to be in the table is actually a bootstrap of this 37 orders that were observed that were inaccurate. So what we're going to have to do to create a proportion over our bootstraps is actually to take all of our bootstrap samples and divide them by this n. So the first thing we're going to want to do is open our bootstrap samples. So remember to open, we want to open everything in StatCrunch. So we want to click this window over here, and then click this window here, and then open in StatCrunch. And we can close this. All right, so once this loads, our first column is only giving us our samples. That's all it's telling us, the number of the sample observed. But what's important is this second column, because it's giving us all of our inaccurate orders. So what we're going to have to do is take each of these orders and divide them by the total to create a proportion. And that's what we're going to use to make our confidence interval. But before I jump into that, let's talk more about our confidence level. So they're giving us a 90% confidence level. So if you remember from the last problem, and skip ahead, I guess, if you guys already know this part, we're looking at, we're going to pretend that's a lovely bell curve, and we're going to be looking at being confident in 90% of it. So we are fully prepared to look at this portion, but there are these end portions that we are not confident in. So this is the same as when we're doing our alpha, which is just 1 minus our percent. So our alpha in this case would be 1 minus our 0.90, or 90%. So our alpha would be equal to 0.10, or 10%. So there's 10% that we need to split over these two tails. So because we have to split it, we divide it by 2. So if we do our alpha divided by 2, 0.10 divided by 2 is also equal to 0.05, or 5%. So we'd have 5% on this side and 5% on this side. So again, if we're thinking about it like a number line, from 0 to 100, we would be looking at the first 5%. So 5% here would bring us from 0 to 5. And if we wanted the last 5%, we would have to do 100 minus 5, which would be 95, which makes sense. So we're going to be looking at this portion for our interval. So we want to make sure we're capturing the cutoffs that are here at the 5th percentile and the 95th percentile. So our percentiles are going to be 5 and 95 for a confidence of 90%. So now that we have all of that, I'm going to do some erasing. Oh, maybe not. All right, there we go. So Now we're going to be able to make our interval. So again, we're measuring proportion, which is the thing we're measuring out of the total. So since we're measuring inaccurate orders, we're going to take our not accurate orders and divide each of them by our n, which is 417. So if we go up to data, and we can compute an expression for all of our data points. So it'll bring you to an expression builder, but I like to hit build here so I can make sure my expressions are built accurately. So what we're going to want to be taking is our inaccurate orders. So we want to double click here on our not accurate orders, and we can use the slash to divide. And then we can enter our n. For me, it's 417, but it's probably going to be different in your problem. So once you have not accurate divided by your n, you can hit OK, and then double check, everything looks good, so we can hit compute. So in this new column, they actually made our inaccurate orders divided by our n, which is our proportion for each. So now we actually have a list of our proportions as opposed to just our inaccurate orders. So now that we have our proportions, we can set up a confidence interval estimate for P, which is what we're doing in the problem. So if we go up to our bar up here, we can do what we normally do, which go to stat, summary stats by column, and we only want to select our not accurate orders divided by our n, so our new column we created, and then we can skip over everything else because all we want to be looking at is our percentiles that we just made over here. So we're looking at the 5th and 95th percentiles, so you just separate those with a comma. You don't have to worry about storing it in your data table, so we can just hit compute. So we'll have to scroll over to the end, but our end limits for our interval are given here. So once we have those entered into our math lab, the second part of the problem is asking about if the intervals overlap and if it differs from the interval they give us in the problem. So my interval is from 0.062 all the way to 0.115. And if you're having a hard time thinking about which one is wider or which one is narrower, or if they're the same size, this is usually a good exercise because you can always subtract one from the other, and depending on which one is either larger or narrower, will give you the answer, but I like to draw a number line. So the numbers I calculated are here, the 0.062 and the 0.115, but they also give us a comparison interval, which is from 0.066 to 0.112. So if this was a number line, these numbers would actually be inside of the one that I would make for my numbers. So I know that my interval is wider because it covers more of a distance than the interval that they gave us. So that's a good way to visualize the second part of this problem. All right, guys, so moving on to the next one. This problem says to list, it says listed below are student evaluation ratings of courses where a rating of 5 is for excellent. So using the bootstrap method of 200 bootstrap samples, construct a 95% confidence interval estimate for mu, which is your population mean. So how does this result compare to the confidence interval that they're giving us here? And then using only the original sample data. So you want to make sure that you are clicking into your bootstrap samples, which are here. You want to make sure you click this little grid icon, and then it will load very many bootstrap samples, which might take a second. So You'll see here, there are very many data sets. So you want to make sure you click the little blue window over here to open all of these in StatCrunch. So while that's loading, we can talk about the confidence level. So they're telling us to construct a 95% confidence interval estimate. So again, if we're thinking about it in terms of a bell curve, we're confident in 95% of what's in here, which would leave 5% that we aren't confident in. So we'd have to split that 5% over the two tails of the problem, which is the same way as when we use our alpha, which is 1 minus our percent. So alpha 1 minus 0.95, which gives us 0.05. And then because we're splitting it over the two tails, we take our alpha divided by 2, so we can find the area for each tail. And 0.05 divided by 2 is just 0.025, or 2.5%, which is half of 5. So we know we're going to be looking at 2.5% on this side and 2.5% on this side. So again, if we're thinking about it like a number line, from 0 to 100, if we know the first 2.5%, we know this distance is 2.5, then we know that this number is just going to be 2.5. The one that's a little different is we know our last distance is also 2.5. So the easiest way to do that is take 100 minus 2.5, which is just 97.5. So we know our percentiles are going to be 2.5 and 97.5. And that's how we get those two. All right, so moving on to our data that we just found that we will need to bootstrap. So once we have our data, we're going to need to construct a confidence interval for our mu, which again is our population mean. So since we need to calculate the mean, we're going to find the mean of each of our bootstrap sample sets. So a way to do that is to go to Stat, Summary Stat by column, and we want to select all 200 samples. So I like to do this by clicking on the first one, and you can just drag it down. And it'll select all of them. I believe you can also hit Command or Control A, and it should select all of them. So just as long as you select all 200 samples, you're good to go. And then we're calculating our population mean, or our interval for our population mean. So we want to make sure we click here for mean, and we want to scroll down and make sure we're storing our output. So we can just select here because we're going to need to use it to calculate our percentiles in the next step. So once you have all 200 samples selected, you have just your mean selected, which you'll see just over here, and we're storing our output. You can go ahead and hit compute. And it'll give us our notification. We made a new column. So now we'll have a mean for all of our bootstrap sample sets made in this column. So our last step is just to find our percentiles so that we can make our interval. So if we go up to Stat and Summary Stat by column, we're going to scroll down, if it'll let me, there we go, and just select the mean column we just created with all of 200 sample means, sample mean estimates, I suppose. And then we're only want to put in our percentiles. So we decided that our percentiles were 2.5. Then we want to use a comma to separate it, and 97.5. So once our percentiles are in, we can just hit compute and make sure we scroll all the way to the end, and our percentiles are given right here, which again calculates to our interval. Because our percentiles are just giving us where the very edges are of what we're confident in. All right, guys, so we're going to be moving on to our last problem that we're going to be going over. So this one is saying that use the geyser eruption duration times in seconds and the accompanying 200 bootstrap samples to complete parts A through C. So part A, they tell us to use the bootstrap method with 200 samples to find a 95% confidence interval estimate for mu. So again, we know we're going to be dealing with our mean, and they told us about our confidence level. So remember from the last problem when we had a 95% confidence level, we were going to be looking at our 2.5th percentile and our 97.5th percentile. That sounds weird to say out loud. But our percentiles are going to be 2.5 and 97.5. So we already know that going into part A. And we're going to be treating part B separately. So we're just going to want to think about this for now. So remember to click this icon to get all of your bootstrap samples. And again, it's populating 200 of them. So sometimes it takes a little bit of time. So once they pop up, remember to click this window over here and hit open in StatCrunch. And then again, it might take a little bit of time. All right, so now that we're all loaded up, again, we were given a number of bootstrap samples and we're given 200 groupings of samples. So we're gonna wanna find the mean because we're finding an estimate for mu. So we're gonna find the mean of each of these sample sets. So we can go up to stat, and then we wanna go to summary stat by column. And we want to do the same thing we did last time and select all 200 samples. So if you select this first one, and I like to drag all the way down to 200, and then we just want to select our mean in the test statistic area, and then go all the way down to our output. We want to store it in the data table because we're going to need to use it to find our percentiles. So now if we go back and hit compute, it'll store everything in our data table. So once everything is stored, we can go back to stat and then summary stat by column again. And then we just want to select our mean column that we calculated. And we just want to enter our percentiles. So we're going to be looking at 2.5 and then just use a comma and then 97.5. And then we can hit compute, scroll all the way over, and these are our endpoints for our interval for part A, once you round to the correct number of decimal places. So the second part is a little different. So part B tells us to find a 95% confidence interval estimate for mu using a t-distribution. So we can't use our bootstrap samples because they're extrapolated data from a given set. So what we're going to have to do is go back to the problem and use the data set that the original bootstraps were created from. So we're actually going to click this blue box here, hit open in StatCrunch, and then it will only open that select small group of original data points that were used to actually create the bootstrap samples. So once that opens, we can actually use a t-stat option in StatCrunch to calculate our interval. because it says to use a t-distribution. So if we go up to stat, and then we can go to t-stat, we only have one sample, and we were given data. So we just select the column that all of our data is in, and we're in chapter 7, so we're going to be doing confidence interval estimates. And then we just want to make sure our level matches our confidence level in our problem. So mine was 95, so I don't have to change it, but you can always change this number if it was 80, if it was 99, if it was 98. You just want to make sure your level matches what your problem has. So once you do that, you're actually all set to compute, and it will give you your lower limit and your upper limit for your interval. So these two numbers make up your interval notation. And that's it for chapter 7.4.